ISTB presents, in association with Dhanmanjuri Community College, DM University Imphal, launching a series of educational programs, recorded online classes for undergraduate and postgraduate students by teachers from various colleges and universities. During this COVID-19 lockdown, every day on ISTB Nongin, 8 p.m. from 24th May 2020 onwards. What's for that? Only on ISTB Nongin.
Good morning, dear students. Today, let us discuss the inventory model 5 under operation research. Economic lot size model with uniform rate of demand, finite rate of production, and having shortages which are to be fulfilled. So we have to derive an economic lot size formula and the average minimum cost per unit time under the following conditions. Demand is uniform at the rate of R units per unit time. Production rate is finite, say K units per unit time. Lead time is 0. C1, inventory holding cost per unit time. C2, shortage cost per unit time. C3, setup cost per run. Shortages are allowed and backlogged. So let us discuss this model. In this model, the production is finite at the rate of K units per unit time. R be the rate of demand per unit time. So the inventory level increases day by day by KR units per unit time. And suppose the production is continue up to time T1. Then we have say Q is the inventory level, so Q equal to K minus R T1. Q is the inventory level and the product increases day by day by KR units. Here K is greater than R. Then after time T1, the production is stopped. Then the inventory level Q consumes daily at the rate of R units per unit time. So the inventory level decreases day by day and becomes 0 at the end of time T2. So we have Q equal to R T2. Therefore, Q equal to K minus R T1 equal to R T2. So this is equation number 1. After time T2, shortages arise at the rate of R unit per unit time, and at the end of time T3, the maximum shortage level is denoted by S. So we have S equal to RT3, where S is the maximum shortages at the end of time T3. S is the maximum shortages at the end of time T3. Then again projection starts after time T3 at the rate of k units per unit time. Then the shortage can be fulfilled during time T4. At the end of time T4, shortages are completely fulfilled. So we have S equal to K minus R T4. S equal to K minus R T4. Therefore, S equal to RT3 equal to K minus R T4. This is equation number 2. So this is the shortage and that is the inventory. So now inventory holding cost. Inventory holding cost is equal to half Q time is T1 plus T2, then C1 is the inventory holding cost per unit time. So this is equal to half Q RT2, then T1. So we can find the value of T1 from here. RT2 by K minus R plus T2, then C1. This is equal to half RT2 taking LCM K minus R RT2, this is K T2 minus R T2 C1. This is equal to RT2 cancel. So this is half RT2 KT2 K minus R. This is equal to then C1. This is RK T2 square C1 by K minus R. This is the inventory holding cost. We find shortage cost. Shortage cost. This is the shortage. Half S T3 plus T4. This is equal to half S is RT3 T3 then T4. From here we can find T4 RT3 divided by k minus r. Then here shortest course is C2, we have to multiply C2 here. This is equal to half RT3, this is T taking LCM, K minus R, KT3 minus RT3 plus RT3 then C2. This is equal to half RT3 RT3 we can cancel into KT3 by K minus R. This is equal to C2 here. So RK T3 square C2 by 2 K minus R. Here is also 2 is missing, 2 here. So this is the inventory holding cost, then this is the shortest cost. This is the shortest cost, this is the inventory holding cost. Now total cost is C3 plus inventory holding cost RK T2 square C1 RK T2 square C1 by 2 times K minus R plus shortest cost RK T3 square C2 by 2 times K minus R. This is the total cost. Then we have to find total average cost. So now total time taken, equal to T equal to T1 plus T2 T3 T4, total time taken. So T1, the value of T1 RT2 by K minus R, RT2 by K minus R plus T2, then T3, then T4. From here T4 RT3 K minus R. This is equal to K minus R RT2 K minus R T2 K minus RT3 RT3. This is equal to RT2 we can cancel, so K T2, then RT3 we can cancel, K T3. This is equal to K T2 plus T3 by K minus R. This is the total time taken. Now average cos equal to C3 RK T2 square C1 2K minus R plus RK T3 square C2 2 times K minus R divided by T, average course. So total time is here. So twice K minus R C3 plus this is RK T 2 square C1 plus T3 square C2 2 times K minus R divided by T. T is K T2 plus T3 divided by K minus R. This is equal to K minus K we cancel. So 2 times K minus R C3 plus this is RK T2 square C1, this is RK T3 square C2 by twice K T2 plus T3. This is the total average cost. This average cost is a function of two variables T2 and T3. Average cost can be denoted by C T2 T3, function of two variables T2 T3. For the cost C T2 T3 to be minimum, we have del C by del T2 equal to 0 and del C by del T3 equal to 0. So you find out partial derivative with respect to T2 and equated to 0 and partial derivative C with respect to T3 and equated to 0, and you simplify and solve these two equations, then you will get the value of T1, T2 and T3. So after solving these two equations, we will get T2 root over twice C2 C3 1 minus R by K R C1 C1 plus C2 T3 twice C1 C3 1 minus R by K R C2 C1 plus C2. So you verify it. Verify it. Then we can verify that del square C by del T2 square greater than 0, del square C by del T3 square greater than 0, and del square C del T2 square into del square C del T3 square minus del square C del T2 del T3 square greater than 0. This is the condition for maximizing or minimizing the cos function. So you have to verify this, then we can conclude that the total cos C is minimum, the total cos C is minimum so after that you find out the minimum cos by putting the value of T2 and T3 in the total average cos, and you simplify, and finally we will get twice C1, C2, C3 are 1 minus R by K by C1 plus. This is the minimum cos. Then next you find out time T twice C3 C1 plus C2 or C1 C2 1 minus R by K. So we can obtain the value of T, putting the value of T2 and T3 in the total time relation. So verify it. Then let Q be the total demand during time T. Then optimal value of Q is R, optimal value of T. So putting the value of T twice C3 C1 plus C2 by R C1 C2 1 minus R by K, this is equal to twice R C3 C1 plus C2 by C1 C2 1 minus R by K. This is the optimal order quantity 2R C3 into C1 plus C2 by C1 C2 1 minus R by K. So this is the economic order quantity, this is the total minimum cost, this is the time interval between successive run, this is the optimal order quantity. So this is the total cost. So today let us stop here, and next class we will try some more problems. Thank you.
ISTB presents, in association with Dhanmanjuri Community College, DM University Imphal, launching a series of educational programs, recorded online classes for undergraduate and postgraduate students by teachers from various colleges and universities. During this COVID-19 lockdown, every day on ISTB Nongin, 8 p.m. from 24th May 2020 onwards. What's spotted? Only on ISTB Nongin.